and share my screen. I'm going to share this one. Okay, I am recording and I'm sharing my screen. Okay, so slides. Oop, wrong slides. These slides. All right, so we're going to start databases now, and let me check and see what microphone I'm using. Okay. Yeah. Okay. All right. Okay. So introduction to database programming. We're in chapter 17. My internet says my internet connection is unstable. Okay, I hope it's not. Hello, hello. All right, that's better. Oh, man. Okay, so introduction to database programming. In this chapter, we're going to learn about. Well, we pretty much know. Say, Rain, have you had a database class?
I was supposed to be taking a databasing class this semester.
Oh, okay, but okay. So is this stuff kind of new to? Okay, but this stuff is kind of new to you then.
Yeah.
Okay, good. Because I don't want to be redundant here. All right, so we'll describe the hardware components of a typical multi-user system, database application, how a relational database is organized, how tables can be related, how tables in a relational database are related. We're going to learn about SQL statements. We're going to learn about the select statement. Let's see if I can start the slideshow here. What does that do? Okay. Related, select statements, insert statements, update statements, and delete statements, the two most common, or the four most common SQL statements. Might be the only ones. Describe the use of ADONET components. We're going to sort of learn what a data adapter is, a SQL command, connecting to the database, a data reader, what a data set is. These are all kind of ADO.NET things, and a data table. Compare the structure of a data set with the structure of a relational database. Okay, sure. Describe concurrency. Describe especially what optimistic concurrency is and what last in wins means. And describe two ways you can create ADO components. Okay. So this is a simple client server system. We've got somebody at a keyboard. We've got a network. We can have somebody else at a keyboard someplace else. And then we've got this database server here, which can be serving multiple clients. The three hardware components of a client server system: we have clients, which are computers. We have a server, which is a computer that's got the database in it. And for us, when we're doing this stuff, the computer and the client and the server will be the same, because we're going to just be using databases. We're going to use the database in Visual Studio. So that'll be the database server, and then the network. If the database server were in a different computer than the client, then we'd need a network too. Typical high-powered PC over a LAN, IBM, big IBM computer, big Unix-based mainframe. That's what the databases usually, where they usually reside. The client part. Oh, a client server can also consist of one or more PC-based systems. Today, that's a lot more common because PCs are like way more powerful than the mainframes of yesteryear. And then individual systems and LANs can be connected together also to make a wide area network. So the typical configuration is that you've got the client and you've got SQL queries going from the client to the server and results coming back. Each server requires a database management system if it's got a database on it, such as Microsoft SQL Server. And processing on these database management systems is typically referred to as back-end processing. Clients, front end has SQL interface, SQL queries, usually a data access API. We'll see what all these are. Structured query language. This is all not that important for what we're going to be talking about. All right, so let's get into what a database is. So here's a table. This is a database table. A database usually consists of a bunch of tables like this. Here we have a bunch of tables that make up the Mike Muroc, whatever the A stands for. Oh, Associates. Mike Muroc Associates Books Database. So Mike Muroc over there has got a customer database, which I'm probably in. And then there's invoices, and you notice there's a customer ID here and a customer ID here. And there's an invoice ID, and there's an invoice ID here. So these are invoice line items. There's maybe several invoice line items in an invoice associated with an invoice. An invoice line items contains line items of products. So there's a product code here, and then there's going to have to be a products table, and with a bunch of product codes. Here's some little details here. We've got a state code here, and that sort of connects to a states table here, which has got the full name. And I'm not sure where this order options fits in. But the important things here we see is this customer ID is the same as this customer ID, and that's kind of how they connect. That's how these tables connect. So that's how they are related. So we've got tables here, and they're all related to each other in some way or another. Product code is related to this product code, invoice ID is related to that, customer is related to that, and so on. So if we go backwards, back to here again, here's the products table. And so we've got a product code, we've got a description, we've got a unit price, and we've got an on-hand quantity. And so there's one row per product. A relational database uses tables to store and manipulate data. Each table consists of one or more records. They can be called records. They can be called rows. In relational algebra language, which is what relational databases, that the math underneath relational databases is called relational algebra. And so a record is in that terminology is called a tuple. So tuples, rows, and records, all the same thing. Each row contains one or more fields. These are like the columns, and so a row intersection with a column represents a single item of data. So in that case, it would be like this row here. We got a row here, And we've got these columns, 4 columns, and the intersection. This is an item. This is the unit price of ADC4 of the ADC4 product, and the relational algebra term for this is called attribute. Attribute. RIBUTE. And most tables contain what's called a primary key, which is a single field that will uniquely identify each row in the table. So in this case, the product code is this primary key, and this primary key is going to be unique. This code is going to be unique, which means that like this code is DBR2. DBR2 stands for this product. There's no other DBR2s. This row is the only DBR2 there is. And so this DBR2 uniquely identifies everything else in this table, in this row, or in this record, or in this tuple. Okay, and so this is the primary key. Okay, that's the primary key field. The rest of these are just simple attributes. This is all terminology we're talking about. Some database management systems allow you to find more than one non-primary key. It's still a key. It still will uniquely identify a record, but it's not what is considered a primary key, the primary key. It's not, and you'll see other ways where this primary key becomes important. A table can also be defined with one or more indexes, and that has to do with they're kind of like they're sorted columns, and so it makes it easy to identify that value, or to sort, to identify records which contain a particular value in one of these fields. Like, for example, if we have, that's not a good one. Well, okay, let's say we have indexed, let's say we do a lot of searches. For example, let's say we do a lot of searches on unit price. And let's say, lots of times they're doing stuff like, we want all the books less than $40, or we want all the books more than $60, or whatever. We might index this field, and then it'll allow us to more quickly do searches based on values in that field. I'm not sure we're going to get too much into that, though, in this course, but it's just good to know. An index is automatically created for a table's primary and non-primary keys. So it's for example, this is the primary key, so there's an index created for this table, and what it does for us is it actually creates another column. It actually creates another column that you can't see, and it's got all these values it's got these values listed in alphabetical order. So they're in alphabetical order, which means that if you're looking for this one, for example, if you're looking for CF or CRFC, and you're looking for it over here, this is in alphabetical order. So that means you can do a binary search on it. A binary search will let you find something in much more quickly. If there were 1,000 books, you can find a particular product code in what the math is log to the base 2 of 1,000, which is 10. So in 10 searches, in 10 comparisons, you can find a particular value. And so indexing is a way to set up these columns. So if you're looking for a particular value in a column, If you have an index, you can find it in log to the base 2 comparisons rather than having to compare each one down the line until you find it. If you don't have this index, let's say for product code, let's say you don't have an index for product code and you're trying to find product code JAVP, you have to start at the top and say, is this JAVP? No. Is this finally till you find it. So you're just going down the line. And the worst case is that you look at every one. I mean, if the worst case is that it's not in there and you end up looking at every one, you have to look at every one before you know that it's not in there. So if you have 1,000 books and you're looking for a book that's not in there, you're going to do 1,000 comparisons because you got to compare each one to see if the product code is what you're looking for. If you have an index, it's log to the base 2 of that. It's only 10 comparisons. That's not that important, but it's a binary search. This is 148. Have we had binary searches yet in this class? Have I taught you binary searches yet, Rain?
I don't. Wait.
Have I taught you sorting? Have we covered sorting in anything? Did we cover sorting in 128?
I believe we did, but I'm not 100% sure.
Okay. Well, okay. So it's related to sorting. You have to sort. You sort it first, and then you can do binary searches on the data. If the data is not sorted, then you cannot do a binary search. So it's all related to that. You just have to know about the existence of it. You don't have to know how to do it or anything in this class, but basically that's the idea. All right. So here's an example of two related tables, which we looked at before: invoices and invoice line items. So we have our invoice ID here, and in this invoice, yeah, this is an invoice ID. So this is the invoices table. That's this table. And the invoices line items table would be this table. So this is the primary key for the invoices table, just this. You got to take both of these. You have to take both of these together to make the primary key for this line items. So since invoice ID alone is the primary key, you'll only see 141, you only see 142, you only see one, you'll only see 43 once, 44 once, and so on, because that's a primary key. It has to be unique. So for invoice 46, for example, this is invoice 46. It's for this customer. Just one customer per invoice. You're not going to have more than one customer per invoice. So one customer, there's a date, there's a total amount, there's a sales tax, there's a shipping cost, and there's a total invoice total. Whereas if we look at line items here, if we look at this one, we see that 46 actually has 1, 2, 3, 4 items on it. Invoice 46 has 4 items. It's got this product and this product and this product and this product. What are these products? Well, I don't know. They're described here, but that's not important now. We just have these 4 products. What's important is the price and the quantity. So if, for example, invoice 47 has got 2 line items, but this particular product appears 4 times. See, so an invoice line items table will only have one for a particular invoice. You'll only see a product code in there once. So we're not going to see DB2R again in invoice 47 because this invoice ID plus product code, that together has got to be unique. And so that means that if 47 and DB are 2, it's got to be only in there once. So, and so that's why if you actually are buying more than one DBR2, then you need to have a quantity field. So anyway. And so, you know, of course, the way this is calculated is for 47, we take 4 times 180, and that's why this number is so big. 4 times 180 plus 5750 equals this number. All right, how tables are related. Tables in a relational database are related to each other by their key columns, which is what I just showed you here. Their key columns. A column that identifies a related row in another table is called a foreign key. So in this case, this is the primary key in invoices, and these together make up the primary key in invoice line items. But this particular field right here is a foreign key into this table. And this right here is a foreign key into the products table, which is this table. See, this is product code. So this product code is the primary key for the products table, and it's also a foreign key right here, because that refers to the row in the product table that represents each of these product codes. So, so that's a foreign key. Usually a foreign key corresponds to a primary key in a related table, which you saw that it does. However, it doesn't necessarily need to be the primary key. It just needs to be a key. It just needs to be a key value. So it can be any sort of key. Now, I don't see any other fields in here that could be keys but not primary keys. Let's see, how about this one? Possibly the description field. Possibly the description field would be unique. Because normally if you have two different books with two different product codes, they would have two different descriptions. But it's possible that you have two books, they're two different books, so they would have two different product codes, but those two books have the same description. I mean, that's possible. So we aren't going to, you know, bank on it or anything. Let's see, are there any other tables here that could be? Well, here, for example, the states table. The state code is definitely the primary key, but there's no two states that have the same name, so this is going to be a unique key. So you could, in fact, have some other table over here where instead of having the state, this state is the state code, but it's possible that you have it where you actually have the full complete state name, and then, you know, you can say that they are related. You could say that this is a foreign key into this table, and it's you're accessing not the primary key but this other unique field, which would be the state name. All right, when two tables are related via foreign key, the table with the foreign key is referred to as the foreign key table, and the table with the primary key is called the primary key table. So, you know, this is like a foreign key table when we're talking about invoice ID alone, and when we're talking about product code alone, you would call this the foreign key table, and you'd call this one the primary key table, and this the primary key table. But these together are called a primary key for this table. Relationships between tables in a database correspond to the relationships between entities, the entities they represent. The most common type of relationship is a one-to-many relationship, one-to-many. But tables can have one-to-one or many-to-many relationships also. So by by one to many, we mean one to many. Oh, there's only one here. One to many. So, all right. In Server Explorer, we will see that with. Do I have a? I don't have it up. I don't have anything up. Okay. Let me quickly open up something here. So here on this side, Server Explorer, we haven't done anything on this side yet. So this is a chapter 2020 thing, and so we've got this database here. This is the books database, and we look. It's got all these tables here. Here's all the tables: customer, invoice items, invoices, and these some other things. So if we look at the customer table, we see these are the fields of the customer table. We can right-click on this and show the table data. And it looks like this. These are customers with customer ID. Products look like this. This is something different. This is a different database than the books, looks like. Oh, this is the design of this table. Let's see if I can look and see what the table is. Okay, yes, this is the same database. So here's product codes, descriptions, prices, and so on. Invoices. Okay, so here's a bunch of invoices. So there's a customer ID, invoice ID, and so on. Anyway, let's go back to this. All right, so here this is the design view window for the invoices table, and so okay, so we're talking about. In fact, maybe I'll just leave it this way. So we are talking about the design view window, which for invoices we can look at that. Open the table definition, and we see here's the design view. The first field is the invoice ID. It's got a little key there, which indicates primary key. And we have, it's an integer field. Here we have a customer ID, and that's going to be a foreign key. See, this is a foreign key right here. Foreign keys. This foreign key is called, it has a name. FK underscore invoices underscore customers. That's a name. And this is the field, and it points to the customer table, which we have here. So that's that. And so this is, we use this to design the table, and so we can add another field. You know, we can add another field down here if we want to. Let's see, this table, want to add another field, we can. This thing's got properties. Is there properties around here? Properties, unit price column, properties, you know, and so on. Product code, properties. This is a, let's look at the customers. Customer ID. This is an identity increment. This means, what that means, identity increment, identity seed. What that means is when you look at these customers, this customer ID is just an incrementing field. It's called a surrogate key, because it just goes up, and so when I add a new customer, it's just going to add it down at the bottom here, and it'll go in as 700. All right, so here's some common SQL data types. A bit, just 1 and a 0. There are these character fields. There's 4 different kinds of character fields. And we'll talk about the differences in these later. V stands for variable character width. size. Char is just a fixed size. N means it's Unicode, so it's 2 bytes per character. These are just ASCII, so they're just single bytes per character. There's date fields, date time fields. There's different numeric fields, decimal numbers, numbers with decimal points. This is floating point, also numbers with decimal points. Integers, there's this one's like maybe from 0 to 256. This is like from 0 to 2 bytes, 0 to 65, 535. This one is an integer field, which is 32 bits, goes up to 4 billion or whatever. And then big int is the biggest number, the biggest integer number that SQL can hold. Then there are these money fields, which are used for dealing with currency. Here are these tables that we were talking about earlier. I showed you this earlier. The tables that make up the MMA Books database. It's the same as this database here, the MMA Books database. Got customers, line items, products, states. And here's the syntax of a select statement. This is if you're going to display out a bunch of data. You can do the word select and then the columns that you want to display out. And then you name the table. And then this is like a selection criteria where you can reduce down how many you want. And then this is an ordering. So for example here, select the name and the city from the customers where the state is equal to Washington and order it by name. And you'll see the names are ordered by name. That would look like this. Let's see, customers. And I can do, how do I pull up a select here? Let me see. And I just like, new query. Okay, so we have customers here, different states, names, so on. So I can do just like what that one was, query. Select name, comma, city, I'll do city, comma, state, from the name of the table, customers, where state equals Washington, single WA. And if we execute that, we see here are all the names, cities, and states, and of all the people. I didn't sort it by anything. Let's do something like order by name. That's going to just, like it's ordered by name here. We can order by city if we want to. And we can do order by city, then by name. And then we get K, Kirkland, Mountain Terrace, Olympia, Pullman. There's a couple people from Pullman, and see they're in alphabetical order inside there. 3 people from Seattle, and you see these. Huh. It's not in alphabetical order. That's weird. GAM. Wow. I wonder why it's not ordering by. Oh, I know why. Can you see why? Seattle is spelled wrong. This is S-E-A-T-T-L-E, S-E-A-T-T-L-E, and this is S-E-A-T-L-E. So with Seattle spelled with one, I don't know how many T's Seattle actually has.
2.
2, okay. Well, So this one is definitely alphabetical order because there's only one of them, and then these two are in alphabetical order. All right, that's weird. All right, so yeah, look, even here. Seattle spelled wrong, Seattle spelled correctly. That's pretty funny. All right. How to query a single table. The result of a select statement is the result table or the result set. The select clause lists the columns to be included in the result set. It can also list calculated columns, which are calculated from other columns. So you can do something like, I don't know. Can we do an invoices or something? Well, anyway, I'll show you that later. So you can, it's almost like with Excel, you can cells calculate, you can have calculated columns where you have this additional column here. Let's see if I can make something. What is let's see what this table looks like. And let's do I don't know, sales tax plus shipping, invoice total. We can do select from invoices. Select, how do you do a calculated column? Select sales tax, comma, shipping from invoices. What does this look like? Sales tax. It's like this. And can we do, let's see if this works. I'm not sure how this works. Sales tax. I'm going to just do this. Sales tax times 2. Does that work? Ah, it does. There we go. Sales tax times 2 is that. So you can name this, and this is different in different databases. But can I do as ST2 or something? Does that work? Ah, yes. See, that's how you name it. So now I've named a new column called ST2, which is actually like a calculated column. The from clause names the table. The where clause names which rows should be retrieved, and you can restrict them. See, that's where the where clause is. And then the order clause, means you can order them. Oh, you can use an asterisk to mean everything. So if you want, you can do asterisk. Well, you can do this, asterisk. You can even do that. So that gives all the rows, and then at the very end, it gives us this ST2 column. See, that's because of this. All right. Okay, and then we can join tables. We have this join thing where when we're saying in the table clause, we can actually connect up two tables, and they're usually connected up by the columns, and they're usually connected up by these foreign key primary key columns. So we can do something like the invoice ID and the invoice line items. So if we do select, I'll just do asterisk, from invoices, inner join, invoice line items, on invoices, I got to do it this way, I guess, invoices, invoice ID equals invoices equals invoice line items dot invoice ID. And what is this going to look like? So we have, so it's going to connect up the invoice. These are the line items ones. So we see invoice ID 3 times here, 18 3 times, because there must have been 3 line items in here. These are the products. So that's how we can connect. You see, from, this is the table field. So that's like a table. You join these 2 tables together into one big table, according to this. So, and you can get really fancy. So here's a select statement that joins data from invoice line items and products. So we're selecting these things from this thing, invoice items, inner join products on that, where the invoice ID equals 46. See, so this is going to display out the joining, these 5 columns, 1, 2, 3, 4, 5, from this table here. And we're restricting it only to invoice ID equals 46. How to join from 2 or more tables? Yeah, so you can join as many times as you want. There's different kinds of joins, which we'll learn about. There's joins, inner joins, left joins, right joins, outer joins, all these different kind of joins. All right. Next, there's insert statements. That's how you add something to the table. So you can insert into a table, and then you list the columns, and then you list the values for each column. And here, order matters. So this is an example. We're going to insert a new product into the products table, and these are the fields we're going to put in there. Now, there can be more fields in this table, and there should be some type of default setup, or default should be defined for those columns here that are not specified, because there's going to be data going in, and you know, great. Okay, so this says 1, 2, 3, 1, 1, 2, 3, 4 fields. How many fields are in a product table? 1, 2, 3, 4. Okay, just 4. Here's something clever. You notice that we want to have an apostrophe in this name, in this data field here, but we use these apostrophes, or we use these single quotes to enclose what the data value is. So if we actually also want to have an apostrophe in the name, we put 2 apostrophes in a row, and then that'll make one apostrophe. So when we look at this data here, like for products, we see that there are all these apostrophes here. When we enter those records into this table, we would put 2 apostrophes there, and it makes 1. And updating is similar to inserting, except for you use this format, set something, and you can make set unit price equals something, comma something. You basically specify it this way. And then you have to specify which records you want to update. The records have to be in there, and you specify which record, and you use the same kind of where clause that you do in the select. So you see where in this update, and for setting, it's like this: something equals something can be comma something equals something, comma something equals something. And delete is simply delete from a table, and then you use the selection criteria to identify which records you want to delete. Like, for example, this one, if you want to delete customer ID number 558. And so that pretty much covers all the statements that we care about. Here's we we talk about a .NET language, and a .NET, what makes a .NET language is that it relies and uses .NET classes, and these are some of the classes that are these classes that are provided in the .NET family or the .NET framework. This is a special connection property. If we go back to here and we look at some data over here, let me Solution Explorer. If we look in Customer DB here, we see this is .NET class system.data, system.sql client. These are .NET classes that we're using. And in there, we've got the connection, SQL connection. That's comes out of .NET SQL client, SQL command, SQL reader. These are all from these methods that are provided in these classes. Connection, command, data reader, data adapter, and these are the ones that were data providers. We use that one. We aren't using these. We use this one though. Yeah. And class names for the data providers, SQL connection. These are the commands for SQL Server, which we're going to use. This is the directive, which I showed you earlier. These are basic ADO.NET Components, adapter command. This is how a data set is what you basically will, from the database server, you'll grab out a data set and you'll manipulate the data set, and then when you're all done, it gets written back in again this way. So two users can be working on copies of the same data. Okay, so now concurrency. So what happens when two users want to access the same data and they both want to update the same data, and they're both using it? Some user has got a data table out here and they want to update it, and some other user's got another data table out here and they want to update. What happens? How do you manage if both of them want to update a single record at the same time? Two users want to update the same row in the database at the same time. The second user's changes could overwrite the first user's changes. Not unless we have, that can happen unless we have concurrency control. ADO.NET uses what's called optimistic concurrency. And the way that works is just before you do the update, you check to make sure that the record that you're updating is the same record that is got the record that you're updating has not changed since you first looked at it. So you grab the data record, it's got all its values in it, and then you decide what your update is, so you construct the update statement. And then when you do the update, you do one last check to make sure that the data record is exactly the same as it was when you first grabbed it out. If it's not, then somebody else made a change to it, which means you have to start all over again. A concurrency exception occurs. If optimistic concurrency isn't in effect, the program does not check to see whether the row has changed before an update or a deletion takes place. Instead, the operation proceeds without throwing an exception. See, this is if we're not using optimistic concurrency. This is referred to as last in wins. So if I want to change, if I want to change this product, which one are we using? Oh, this is old. We're using We're using Murrock C# 2015. So if we want to change this, let's say we let's say we want to change the price of this to 56 from $56.50 to $59 or something, or let's say we want to change the quantity on hand because we sold a few of them. Then if I go in there and I grab, let's say I go in there and I grab this record out, and then I'm going to change it, and so I grab it out, and then somebody else goes and grabs it out because they're going to change this one, and then I go in there and I make my change to this one, and then the other person goes in and makes their change to this one. If they are rewriting the whole record, they will overwrite my new value with the old value. So if you think about that, you can see how that can be a problem. And so in other words, the last person that wrote the record wins, and the first person that wrote the record loses. So to avoid concurrency errors, they rarely occur, and as a result, optimistic concurrency is adequate. If concurrency is likely to be a problem, a program that uses a data set can be designed so it updates the database and refreshes frequently. It can be designed so it does updates frequently. And then concurrency errors are less likely to occur. Another way is that a program just retrieves one data row at a time. And then if you're just doing one data record at a time instead of a whole data set at a time, there's less chance that you'll be a conflict. Traditional systems that don't use optimistic concurrency, they will, there's usually some flag or something where you say, okay, I'm going to mess with the products table for a while. So then you lock it. You say, okay, is there anybody else using it? No. And then you lock it. And once it's locked, no one else can use it. And you go ahead and do your thing. And once you're done, you release the lock, and then other people can use it again. And that's another way of managing concurrency. But a disadvantage of those other ways is, let's say you want to mess with invoices and you want to mess with invoice items. Let's say you want to mess with invoices and invoice line items, and somebody else wants to mess with them. You might, let's say it's a sloppy management of concurrency. So you need to lock both these tables because you're going to mess with both of them. So you grab the invoices table because no one's using it. In the meantime, someone else grabs invoice line items because no one's using it. And then you want to grab invoice line items also, but you cannot because somebody else has grabbed it already. Meanwhile, the other guy wants this one, but you have it already. So the other guy is busy holding on to this, waiting for you to be done so it can use this. In the meantime, you're holding on to this on the invoices, waiting for invoice line items to be done, and you're both sitting there waiting for the other person to release it, but they're not going to because they're waiting for you to release it, and that's called a deadlock. And so deadlocks can be a problem. And so usually there's some overriding system thing that monitors, and boy, these two people have been waiting for these tables for a long time, and nothing's happening. There must be a deadlock. So then the system says, all right, everybody release all your tables and start over again. And then, hopefully when they start over again, they'll do things in order, and then there won't be a deadlock. Both of them. If somebody wants to do something to both tables, they'll get them both. They'll get them both, and they'll be able to do it. Meanwhile, the other guy is waiting for both tables. And so, but optimistic concurrency avoids all that. I mean, that way that I just described of avoiding concurrency problems, that can be complicated. But big systems where there's lots of people using all this and that, and you're waiting, you have to grab up a whole bunch of resources before you can do anything. They have to use those more complicated concurrency avoidance systems, which can cause in which deadlocks can occur. But when we do optimistic concurrency, deadlocks will never occur, although somebody might there could be somebody that sits there trying to make an update to a table, and they keep on doing it, and they keep on doing it, and they keep on getting bounced out, and so that's a possibility also. Here's they call a data set object hierarchy, data tables, data columns, data rows, constraints, and so on. In ADO.NET, you can also access databases directly. In most systems, we access databases directly, but with ADO.NET, they provide this data reader business, data sets, and that helps when you have lots of different programs trying to access the same database. So we use this data sources window in creating ADO.NET, creating the data sources window. So this is sort of a thing. We'll see how this works with these, components down here. This is the connection ADO.NET objects created using code. So we can create them this way using code. And that's precisely what we saw here. It's creating these things using code. And that's it. So that's my little presentation on introduction to databases. And so next time we will actually dive in there and start making some databases. All right, so I guess that's it for today. It's 4:24. Any questions?
Nope. Just hope I don't ever get into a deadlock when it comes to databasing.
Oh yeah, okay. Well, we probably won't even get that far. We probably won't get into testing it because optimistic concurrency works pretty well. We can set up some things where we're actually testing to see that optimistic concurrency works. We can step through some things, but that does actually happen on the web when everyone sort of logs in and they go to the form, they want to fill out something, or they want to buy something. Then we can experience some potential deadlock cases that we see are avoided by using the optimistic concurrency. But it's usually the case where you have to set up something to get the thing, because how often are two programs hitting something at exactly the same time? That's really rare. So, but anyway, yep, that's what we want to avoid. All right, so I will. Today's Tuesday. I'll see you on Thursday.
Yep.
Okay. Thank you.
All right. Goodbye.
Bye.